All right.
Okay. Okay. So um, okay. So part 2. Do you have any questions for part 1?
Not really.
Okay. It was a little bit confusing though.
I just know in like the textbook it like told you to go like to this one place, and I went there. I'm like, I have no idea what I'm supposed to do here.
The random.org place.
No, it was something else. What is it called?
Oh, on the reading?
Yeah. Onlinestatbook.com.
Oh yeah.
I was like, what the heck is this?
That was a little confusing. I know. I think it was basically just to like show you kind of like what, like how the shape of the distribution changes when like it's different types of graphs.
Mm-hmm.
But for part 2, what did you get for like what numbers did you end up doing? Or what was the mean?
My mean was like, I pulled up. It was 42,820.
Mine was 420. So my sample mean for C was unusual because it was far from the middle.
I put mine I put mine as usual because it was kind of closer to the middle,
Okay.
but I don't know.
Yeah.
I wasn't sure what is defined as close to the middle or not.
Yeah. So I think like just more on the outside is not because mine was, well, I guess if yours was 42, it was closer. Mine was like way on the outside. Okay, D. Compare your mean from question 7A to the means obtained by at least 3 other individuals. What do you notice? In practice, you only get to see the means from the samples you draw. You do not get to observe any other mean that could have occurred. Okay, well, we can't really compare to 3 other people.
Yeah.
But ours were pretty similar. I don't know. Do you have anything else to say?
No,
Okay.
like, there's not much to say because there's not much that we're comparing it to.
Yeah. Um, okay, 8A. What is the shape of the distribution of the sample means for all such samples? I put normally distributed. What did you put?
I put normally.
Okay, and then that's because of B, that the parent population is normal.
Yeah.
Okay, what is the mean of the sampling distribution of sample mean scores for all such samples? Did you get that one?
How do you know?
So it's just the mean, so it's just 529.
Mm-hmm.
So
Oh, are you talking about for C?
yeah,
Yeah, C is just the mean.
yeah. Okay, how do you know, like how do you, so I was like watching the video for like extra help,
Mm-hmm.
and I don't like, I get that when the parent population is normal, then the shape of the distribution is normal, but I don't get like what the population, like how is it normal in this one?
I don't know.
Okay. Maybe because it's less than 30.
Possibly. I don't know. It's just I was like all over the place in this whole thing.
Okay.
It was weird.
For D, what did you get? Or did you get this problem?
See, I kept referring back to the thing, like the example, but I just didn't get what it meant.
Okay.
Because like I saw the answers like 37 something on the answer key. 37.734, but I don't know how. I mean 35.734, but I don't know how they got that.
Okay. So hold on, let me get my notebook. So in order to find the standard deviation of distribution of sample means, you have to do the standard deviation over the square root of the sample size. So
Okay.
the standard deviation, which is 113, and then you divide it by the sample size, which is 10, but you take the square root of 10. So that's how you get 35.75.
Okay. I just wasn't sure what the N was. I
know. It's really confusing.
Because I was looking, I was like, it never tells me what the freak N is. So I wasn't sure what it was. Okay, that makes sense.
Okay. I don't really understand B though, but I want to figure it out because I'm worried that if we don't know what it is, we won't.
B?
Yeah, like I like understand that the concept, but I don't understand. Like, I just want to like, I don't know.
You don't fully understand it.
Yeah.
Like you understand like enough to like get the right answer, but you don't know.
Yeah.
The full meaning of it. Like if they ask something more in depth, you're like, I don't know.
Yeah, exactly. So I'm just reading the like lesson. Do you get it?
Not really.
Neither. Okay, well, it says like in 3.1, like in the lesson 6 reading, it says a sample size of 5 will probably be sufficient to ensure that the sample mean will be approximately normally distributed. That's if the parent population is almost normal. But then on the first one it says, oh, I just stabbed myself in the eye. It says if the parent population is normal, then the sampling distribution of of the sample mean will always be normally distributed, no matter how many observations are selected. But how do you know when the parent population is normal?
I don't think they've taught us that yet.
Okay.
I think they'll probably just, in the questions, they'll probably just tell us whether it's normal or not.
All right. Should we take the quiz then?
Yeah.
Okay. When you're taking a sample size of 5, what is the shape of distribution of means histogram when the parent population is right skewed? I think it's normal.
Yeah. I think you're right.
I'm so confused. Okay. Actually, no, I don't think it is. I think it's, what do you think? You think it's normal?
No.
For 3?
Yeah, I don't think it is. Because I went back to that reading, and it says, like, if for tremendously skewed distributions, a much larger sample will be required before
It's normal.
the sample distribution mean is approximately normal.
Okay, I think it's skewed right then.
Yeah, I think it's skewed right too.
And then I think number 4 is normal.
Yeah, with 100.
And then 5 I think is normal as well because of what it says there too.
Yeah. I'm pretty sure 6 is normal too.
Yeah, me too.
I think all of them except the data drawn from a skewed right. The population skewed right and the sample size is small.
Okay.
So it's asking when they're all normal, right? Yeah. That's what I think, at least.
I don't. Okay.
Because that's like what we just said.
Yeah. I know, I think you're right. Okay. Okay, I put everyone then except for the third one.
Okay.
The best explanation of the central limit theorem.
Oh, man.
I think it's the last one.
Yeah. Let's make sure it's the same answer. Is that the one that says if the sample size is large, the shape of the distribution sample means will be approximately normal?
Yeah.
Okay. Yeah, that's what I put too. A lot of those are really close to the same thing.
Yeah. Okay. What is the mean of the distribution of sample means? Isn't that just 10?
Yeah, 10.
Standard deviation 6.
It's 1. Right?
Of the standard deviation?
Yeah, isn't it 1? Because it's like 6 over the square root of 36, which is 6.
Is it?
That's what I thought. Maybe I'm wrong. Wouldn't be the first time.
Yeah. Yeah, you're right. Because it's just. Yeah, you're right. Sorry. Okay. My bad. Regardless of the distribution of the population of the sample. I think it's just normal.
Yeah. I think you're right.
I guess I hope. What theorem? Justify your response to the last question.
Isn't the central limit theorem?
I think it's the law of large numbers. Because the law of large numbers states that if the sample size is large, then the sample mean will typically be close to the population mean. Oh, wait. Yeah, no, you're right. Sorry. I just read it. The central limit theorem states that if the sample size is large, that the sample mean will be approximately normal. Yeah, so that's right, right? Central limit theorem?
I think, yeah.
Okay. I'll try to submit it.
Yeah.
Okay. Oh, wow. I was not expecting that at all.
What?
100%.
Dang. Did a lot better than I thought we did.
I know.
Sweet.
Awesome. All
I
right.
guess we understood it better than we thought.
I know. I feel like we're kind of guessing. Okay. So I stopped the broadcast, I think, but I don't know if it's gonna. I'm gonna try to stop it and see what happens.
Okay.